This is going to be a quick tutorial on how to use the graphing calculator to graph a radical function, in this case a square root, and to calculate the time of a swing of a pendulum given the length of the string. Here we have t, which is time in seconds, is equal to 2 pi times the square root L, which is the length of our string, divided by 9.81. Okay, first we're going to go to the y equals button to bring up the screen where we can put in the function. And instead of t and L, we're going to use x and y. X is going to be our variable for L, string length, and y, which is what we're calculating, is going to stand in for t. So 2 second exponent key will give us the pi symbol. And then we're going to multiply this by the square root, and it's x over 9.81. So I'm going to hit the alpha key and then the y equals key to bring up our menu for putting in fractions. I'm going to hit enter. Alright, now here I'm going to put in x, that's our string length, and 9.81. Oops. There. And a couple clicks over to the right and we are out underneath the radical sign, and we can graph it and see what this looks like. Here is our radical function. Now most of this is happening in quadrant 1, and I'm not really interested in when x is negative here, so I'm going to go to the window key and I'm going to make a little change. I'm going to make the minimum -1 and I'm going to make the maximum 20. That's a good number. And then I'm going to regraph. Now we can see more of our radical function. And it's going all the way from x to 20. Good deal. Alright, so here I can, at this point I can press the second key and then the trace key, which will bring us to calculate. And here I can put in values for x. So I'm going to choose number 1, value. Now, suppose I want to find out how long it'll take if the pendulum is, say, I don't know, 5 meters. Here's our function up top, and when x is 5, the time for a complete swing is 4.89 seconds, rounded. Alright, we can do this again. Second, trace, which brings us to the calculate menu. Value, how about 10.3 meters? 10.3 meters, 6.4 rounded up to the 100th place, 6.44 seconds. One can also calculate this directly on our screen where we do regular calculations. We can press the vars key, arrow over to y vars, and hit enter. Now here's our function y1. Remember, we put in the equation. y1, let's put in a value of, let's see, 6.8 meters, and it'll calculate it right on the screen, 5.23. So in this manner we can see both the graph and we can calculate with it directly on our main screen.